Hey everyone, this is Mr. Tam here, trying to keep you guys ahead of the game. Today we are March 17th, 2020. I thought I would start by reviewing a little bit of molar mass. So let's remember that when we're talking about molar mass, that we can find this information underneath the element name on a periodic table. We'll say, for example, we have the element carbon, whose symbol is C. We have listed under carbon a number of 12.01 grams per mole, or you can redefine it as 12.01 grams per 1 mole. Similarly, this concept could also be applied to, let's say, a compound, and this compound we're going to use is carbon dioxide. Carbon dioxide has a chemical formula of CO2. Now, the only thing that's different between what I did initially with carbon and carbon dioxide is now that I'm dealing with two elements, I have to take both into consideration. So since carbon has a molar mass of 12.01 right here, I'm going to add that to the two oxygens that are now attached to the carbon. So I have to multiply the molar mass of the oxygen by 2. Thereby giving me a molar mass of 44.01 grams, again, per 1 mole of CO2. Now, it's really important, oops, that 2 doesn't look like a 2. It's really, really important to remember that you have to list what you're talking about next to the element in question or the mass in question, because if you don't specify later on when we go on to stoichiometry, you may have difficulty keeping track of all the elements or the compounds that we will be reacting together. Now, let's move on from this. If I were to ask you to find the number of moles of something given a certain number of grams, so say, for example, I have, let's separate this here into a second part. Let's say I'm given 66.015 grams of CO2. Well, I don't really know what that represents in terms of number of moles. So I'm looking for number of moles. But what I do know is that the molar mass of carbon dioxide is 44.01 grams per 1 mole of CO2. Now, this is like any ratio or proportion that you've ever done. So say, you guys remember I always talk about the pancakes. If I have a recipe that requires 2 cups of flour to make enough pancakes for 4 people, well, if I have 8 people coming over, you guys simply always say, hey, sir, that's really easy. I just double the amount of flour I have. In that case, I would require 4 cups of flour. So it's the same thing here. I know that 44 defines 1 mole of CO2. So I'm interested now in how much 66.015 grams represents in terms of number of moles. So I'm going to just punch this into my calculator. It's a good old cross multiplication. And let's not use X here. We're going to use N. That's the appropriate letter for moles. N will be equal to 1.5 moles of CO2. Okay, now, if I were to give you a second example, rather than ask you to find the number of moles, I'm going to now ask you to find the number of grams. So I'm interested in, let's say, 3 moles of H2O. Well, to find 3 moles of H2O, you simply need, again, the molar mass of H2O, which happens to be 18.02 grams. Now, if you guys have any doubts finding that, you're just taking essentially 2 oxygens, which each have a molar mass of 1.01, multiplying that by 2, and then adding that to the oxygen. That represents 1 mole of water. Now, since you have 3 moles of water, you're going to line them up, as you've done always in the past, with these ratios, and you go again for another cross multiplication. This actually will end up giving you a total mass. Let's punch this into our calculator. It's basically 18.02 times 3. Oops. And that gives you a grand total of 54.06 grams of H2O. So that's a kind of speedy review to help you guys remember what we had talked about last week. So if you guys are good with that, please feel free to rewind this video at any point in time. This is Mr. Tam from CRHS. I'm going to now move on to the next part. So after having found the number of moles or mass given these numbers, we are now going to move on to try to figure out the number of atoms given the number of moles. So if, let's say, I'm given 3.5 moles of NaCl. Okay, now NaCl is a classic compound. We use it every day. We call this table salt. And I'm interested in the number of atoms that this number of moles represent. So we talked about this in the past. This is a gigantic number, 6.02 times 10 to the 23, in this case, molecules of NaCl. And this will represent 1 mole of NaCl. Remember, moles is simply a number, much like dozen represents 12. Mole represents a giant number in the form of 6.02 times 10 to the 23. It can be anything. In this case, it happens to be molecules. So I have 3.5 moles rather than 1 of NaCl. And lo and behold, again, another cross multiplication where if I now am looking for the missing number of molecules, I end up with a gigantic number, actually, of approximately 2.107 times 10 to the 24 molecules of NaCl. So that's if I'm given the number of moles. But what if I were to ask you to find the number of moles given the number of atoms? So in this case, I'm going to give you guys a number of 3.612 times 10 to the 24 atoms of gold. Okay, gold is one of my favorite elements, super shiny, super bling bling. And I am interested in the number of moles. Now, I'm going to set it up a little differently. I'm going to say that this represents an unknown number of moles of gold. Okay, it could be bigger than 1, less than 1, it doesn't really matter. But what I do know is that 1 mole of gold will always represent, again, this same number, 6.02 times 10 to the 23 atoms of gold. And when I go to do a cross multiplication of this, I realize that, let's see here, let's punch this into the calculator to see what this gives me. So I end up taking 3.612 times 10 to the 24 divided by 6.03 times 10 to the 23. This gives me 6 moles of gold. Now, this is something I wish I had. That's a lot of bling bling, okay? So that's how you figure out the number of gold moles if you're given the number of atoms of gold. So I'm now going to move on to probably the toughest variety, which if I give you mass, for example, if I say to you that you have 36.0, let's say 36.04 grams of H2O, first thing we have to do is find the number of moles. No matter what you do, you always have to go through the number of moles. That's the general rule of thumb. So that's the n number of moles. I don't know, but I do know that 18.02 grams of H2O ends up giving me 1 mole. So when I cross multiply this, I get very simply 2 moles of water. And then once I am at this step, this is essentially step number 1. At step number 2, I end up needing the 2 moles of H2O because I know, again, Avogadro's number, this 6.02 times 10 to the 23 molecules of water represents 1 mole of water. And I know that I have 2 moles of water. So essentially, I'm just doubling up the number of molecules. This is an X number here, whereby X is equal to 2 times 6.02 times 10 to the 23, which gives me a very nice number of 1.204 times 10 to the 24 molecules of H2O. Now, so far so good. Okay, this is essentially what we have done up to this point in time. So you can actually, with this information, finish anywhere from your workbooks from 6-1 all the way up to, I feel, 6-5, okay, with this information. Let's move on from here, and I'm going to show you guys now something that's new so you can jump ahead on this. The next little segment I want to teach you guys is something called molarity. Now, molarity is just a very simple way of describing the concentration, but whereby the solute is generally, we express it in grams or milligrams as a form of mass. In this case, we are talking about the number of moles over the liter or 1 liter of solution, okay? Just to make our lives a little easier. So let's say, for example, and the simple representation of this is, again, C, which we use to describe concentration, is equal to the number of moles N over the volume of solution, sorry. So what I'm going to give you guys is, I have a little petri dish right here. And in this petri dish, I have 0.56 moles of NaCl. Now, I'm going to pour this into 200 mLs of H2O or water. So this essentially just goes in here, and I'm interested in calculating the molar concentration, or the molarity, same thing, or molarity. So I'm going to now transfer the 0.56 into the 200, and I'll use my formula of C is equal to N over V. Now, very simply put, well, it's already in moles, so I don't really need to worry too much about that. This is moles of NaCl. But as you saw on top there, I said that the amount of solution is always per liter of solution. So we're going to make sure that we convert 200 mLs into liters. So that's 200 divided by 1,000, which gives me 0.20 liters. So I'm going to now transfer that amount here. And lo and behold, when I divide 0.56 by 0.2 liters, I end up with 2.8 moles per liter. Or to abbreviate this, we are allowed the notation 2.8 capital M. And it's just as easy as that. It's very similar to the concentration that we usually do, except that, you know, rather than deal with grams per liter or milligrams per liter, you're dealing with moles per liter. All right, let's give ourselves another problem. So I'm going to tell you guys that my little beaker here has, let's say, in it 0.5 moles of acid, and this has a concentration of 2 molar, or 2 moles per liter. So how do I go about solving this? Well, first things first, I know that I have C, oops, let me just separate this. C is equal to N over V. So my concentration is 2 moles per liter. That's on the left. And then I'll have my N as 0.5 moles. And this is an unknown V. So when I cross multiply, I end up with 2V is equal to 0.5 moles. And I divide both sides by 2. And this gives me very nice answer of V is equal to 0.25 liters, or if I wanted it in milliliters, I could simply multiply this by 1,000 and I get 250 ml, exactly a cup of this acid. All right, let's finish this up by doing one last problem, but this one I would consider it a tough one. Let me erase what you see here. La-di-da-di-da. I'm going to try to erase all of it without actually having you guys lose the formula that's on top. So, perfect. Now, once we get to this point, pretty straightforward. So far, it's just like any other concentration problem we've been doing. Now, I'm going to write it out. I'm going to give you 20 grams of NaCl in 3 liters of solution. I'm going to ask you to determine molarity. So anytime you're given the task to find molarity, you know it has to involve moles. And then because you're given grams, that's really not moles. So step one, I always do is I try to figure out the molar mass of whatever substance I'm dealing with. And in this case, I have sodium chloride. So sodium chloride's molar mass is 58.44 grams of NaCl per 1 mole of NaCl. Now, that being done, I now have to figure out the number of moles. So now I have 58.44 grams of NaCl over 1 mole of NaCl, and that's equal to the 20 grams I actually have of NaCl, but this is an unknown amount of NaCl. So I go and cross multiply. I end up with a number that's approximately, and you guys can correct me if I'm wrong, 0.342231 moles of NaCl approximately. Okay. Remember, the procedure is more important than the actual numbers. Yes, the numbers are important, but we're not actually making the solution. So no need to worry too much. C is equal to N over V because I'm interested in molarity. And now I just plug in my numbers that I've been dealing with, 0.342231 moles of NaCl. And I divide this by the 3 liters I'm given for my solution. And this number ends up being approximately, I'm going to have 3 significant figures for this, 0.114 moles per liter, or 0.114 capital M. So I'm going to end the video here for now. You guys can feel free to email me if you have any further questions. You actually can now start to do pages 6-11 to 6-12 in your workbook. If you do not have the workbook, I will post it up on my website. And just to remind you guys what my website is, it's mrtam.weebly.com. And I will have a special section in there. Haven't really decided what I'm going to name it, but it's going to be kind of the section that tells you this is the stuff we're doing because we're away from school. Okay, I'm not going to put it with my regular stuff, just so that it's easy access for everybody. So I hope you guys are doing well. Take care of your families. Be safe. Don't go out if you don't need to. And I really hope to see you guys really soon. Take care.